Hello, and welcome back to my Kubernetes series. In the last video, we reviewed and deployed the backend for our Nextcloud instance. We installed a 2EM proxy and Redis application, which will make sure to manage sessions and hashing for our Nextcloud. In this video, we will be looking at an nginx web server and the PHP interpreter we need for Nextcloud. So let's review the instruction we consulted in our first video and see where we need to pick up. If we scroll down on the site and take a look at the next steps, we see that the next part of the deployment is the PHP FPM deployment. FPM stands for Fast Process Manager. The instructions indicate a version 7.3. As this version is long out of support, we will create a version 8.1 and we'll walk through the changes I had to make. Further down the site, we see there's a config map for the PHP server, which we will duplicate and mount into the PHP FPM container. The config map contains the user that executes the PHP interpretation, the port that it listens to for PHP connections, and the amount of workers that this deployment can spin up. If we go down a little further, we find the deployment for the PHP container. As I modified that slightly, we will walk through my YAML a bit later on the console. We next find a config map, which I mostly will take over, but I will take a look at them closer on the console as well. Last but not least, we need a service to route the traffic to the different pods we will be running. The setup for this service is straightforward and we'll review the YAML on the terminal. Next step in the instructions is the nginx deployment. Once the PHP interpreter is built and deployed, we need a web server which will receive the traffic and then forward it to our PHP interpreter. There are a few specialties we need to pay attention to. If we look at the section for env or environment variables, we see that the web root is declared as well as the PHP socket. These entries are very important as the variables will be used by the starting container to update some of our configurations. If you want to use a different port for PHP, make sure you adjust this value here as well as in all other spots of this deployment where it is used. Last but not least, we see the config map for the Nextcloud deployment. This config map is copied from the Nextcloud documentation, which we will take a look at in a few minutes. The config map consists of three pieces. Number one is a file called nginx.conf. This file is mounted into the folder etc nginx and contains the configuration for our web server. Number two is a file called default.conf template, which contains the port the web server listens to, the web root, and the includes. These includes are separate additional files that need to be interpreted to make a site such as Nextcloud work correctly. As the instructions talk about Nextcloud in a version 18, we will have to update that part of the config map, as we will be using Nextcloud in a version 27 or 28 if 28 has a final release candidate. Before we move on, I want to highlight two variables that you can find in this file. Number one is the root, which has a variable called webroot. If you remember back a few seconds ago in the deployment, we actually set an environment variable called webroot with a path. The next one is include, which will include different files, and this piece, as well as the web root, will be updated upon the startup of the container by an automated script. File number three is called Nextcloud include template. This file contains the Nextcloud server settings for nginx and is copied from the Nextcloud website. However, we have to review that file closely. The content on Nextcloud website is for a VM or bare metal system, not for a containerized microservice setup. we have to make sure not to double contents. So whatever we have in the first two files, we don't need in the last file. On top of that, we have to modify some entries in that file, such as the PHP socket the web server needs. Now you might ask yourself, okay, we pass this file into the container and then what? As we call these files template and mount them in a certain spot, these files are modified, and once the container starts up, will be updated with the environment variables and then added to the right folder. Last but not least, in this video we will be talking about the service. For nginx we also need a service which will receive the traffic and handle the communications to PHP, receive the answers and pass the result back to the requester. Enough theory for now. Let's head over to the terminal and get started. First things first, we're going to check out the PHP deployment. For that reason, we will switch to my VM, which I use to build containers, and take a look at the PHP 8.1. PHP 8.1. As you can see, I have two files in this folder. The one, PHP 8.1, which mostly aligns to the script that you'll find on the instructions from Marko. The other one is the one that we're going to take a closer look at. I tried to take apart the script on Marko's website and build a step-by-step installation. That allows me to do some error analysis if some issues occur, and it also allows me to easier update a script to a new version of PHP. So let's walk through this script and find out what this script does. We start with downloading the PHP 8.1 FPM Alpine image. We update and upgrade and then add some packages. These packages are required to be able to install the modules that follow. Next, we are calling a script that is part of the container. That script is called docker php xconfigure. We are configuring the GD package to contain the FreeType and JPEG interpretation. We do a similar thing with the IMAP to include standard IMAP and the encrypted IMAP protocol. In a previous implementation of the script, I separated the installation of GD from other packages. Future manual here. I thought that my endeavors to integrate the installation of the GD package with the remaining PHP packages worked. However, when I installed Nextcloud and reviewed its self-check under the administration settings, I found out that this installation did not in fact work. GD was not active and I needed to uncomment the line number 8. I will add in the description below the build file that I used to successfully build the container. I also created a repo on hub.docker.com for which I will post the address in the description and on the screen, as well as the detailed build script for buildah on GitHub. Each of the images I built will be moved there, and I will add descriptions and more details on GitHub, such as how I build images, which config maps and secrets are required for a deployment in Kubernetes, and at some point I will translate the buildah files to Docker. That might take a while though. Anyway, now let's get back into the video. The script then runs through the configuration and installation of all these PHP packages that you see. You can imagine that takes some time. I will record this part, but will post it as a separate video if there is a desire. The setup of the container and the build will take about 30 minutes in total. Alright, moving on. We see next that I'm adding additional packages in line 13. We declare these packages to belong to a virtual group called deps1. Which will make it easier later to remove them once they are not needed anymore. Next, we are configuring and installing more PHP modules. I can already hear your question, but why are we not adding them above with the rest? And you are totally right. However, there are different modules for PHP. Let's take a quick look. Switching over to the PHP documentation, on this site you find the documentation around the different PHP extensions. The first set of extensions are not really extensions. These are modules that are part of the core PHP and cannot be omitted. If we scroll down, we find bundled extensions. These are extensions that can be installed and do not need any additional packages. The next part of extensions are external extensions. These modules might need additional libraries to work correctly. If you, for example, take bzip2, that package needs additional libraries to work, which are bzip2dev and bzip2. If you want to install this PHP extension, you must install these libraries first. And last but not least, the PECL extensions. These are available modules through the PECL repo and can be installed that way. That is why you find different modules and different way of installing these modules. Going back to the terminal and our script, we left off in line 14. This line, similar to the installation of other PHP modules, is a script in itself that is executed on the command line of the container. I define a loop and then hand over the modules I want to install. These modules are then installed on the command line and set up. As you can see, only a few such packages, such as apcu, nginx, but one important one is Redis. As you remember, we have deployed Redis already and want to be able to use that tool and the features within PHP. Last but not least, we are removing the virtual packages again. We are setting the owner of the var www folder to the daemon user and add a few labels. Then we commit to the build. As the build of the container is complete, I will push this container to my registry, which sits on quay.io. I will have the registry address for this particular image on the screen right now for you to use. As the container build takes about 30 minutes, I will stop the recording and be back once the container is fully built. As my container is built, I'm going to push the image to my registry and then we'll be back to continue our implementation. Great, now let's switch back over to our master and we will continue to review the deployment services and config maps to make sure we know how each of these components work and how they interact with each other. As we're back on our master, let's check the folder. So we have to create our subfolders for PHP and nginx, which we'll do next. mkdir 03, and we'll call this PHP to make it easy on us. And we're also going to straight away create a folder for the nginx deployment. Let's enter the PHP one. And we're going to bring in the files we need. Let's start with an easy one. First, we're going to create a persistent storage with pvc.yaml, and we're going to bring in the details. We are creating a persistent volume, which is called Nextcloud. In the namespace Nextcloud, we will use our NFS storage, which is our default. We have read-write once, and I'm going to increase the size and say I want 20 gigabytes. I do have a second one, which I intended to use previously to separate the Nextcloud user data from the Nextcloud instance itself. However, that implementation I could not get to work yet, which will be something for the future. So I will just out-comment it. I do want to keep it, but right now I will not implement this piece of persistent storage. Alright, as we're done, write and quit, and we'll move on to the next file. Let us continue with the config maps. config.yaml, and we're going to paste the config maps. Unfortunately, that came through twice, so we're going to delete the one on the bottom, and we'll walk through the file. So we have a kind config map, the called PHP confmaps in the Nextcloud namespace. The first file in this config map is the www.conf. This configuration is a file which we can recognize by the pipe following the colon. The content of the file is www. Then we have a user and a group. We align those two with the user and the group we defined during the container build. Next, we have two out-commented lines with the www data user. I tried an implementation with this user previously, which worked as well. However, then you have to change the container build, so we're going to remove those two lines. Then we define the port that we're listening to, which is port 9000. That becomes important later when we set up the configuration map for our nginx container, because we have to hand over this port. We'll get to that in a bit. And next we define the process manager and how the process manager can behave, how many max children it can have, how many servers it can start up, and the spare servers and the max spare servers, so minimum and maximum. Marko in his instructions implemented this file directly, or copied this file directly into the container. I, however, thought it was easier to add this piece of information as a config map and then be able to mount it into the container. That allows me to modify the details such as the user, as I just took it out, but it would allow me to be more flexible in my implementation. There is no right or wrong way, it's just a different way of implementing these things. The other config maps we need to address are the Redis session INI, logging INI, and the Nextcloud INI. The first piece, Redis session INI, we define that we have a Redis session handler. This session is handed off to Nutcracker or 2EM proxy, where it will be managed. We are enabling file locking, which is one of the reasons why we wanted to use Redis in the first place. And lastly, we have the session lock retries set to 4000. Next is the logging INI. We are defining the error logs, then we define that we want to log errors but not display them. And last but not least, we are which errors are we reporting. EALL stands for showing all errors. The deprecated will highlight errors for the code that will not work in future versions. And the strict will make PHP suggest changes to the code, which will ensure the best interoperability and forward compatibility of said code. You can find all these errors in the documentation for PHP. I left a link in the video description and will put it also on screen. Last but not least, the Nextcloud INI. Please be careful when following the instructions on fawn.pub. There is an error in the deployment. The config map, which I call Nextcloud INI, was also called Nextcloud INI in these instructions. However, the deployment mounted a config map which was called large uploads.ini. As soon as you change that config map to Nextcloud INI, within the deployment you are good and the container will run. I had some challenges figuring that out, but once I did, everything worked as it was supposed to. Alright, what are we doing in this configuration file? We declare a memory limit of 512 megabytes, post max size of 512. We allow uploads. The upload maximum file size is also 512 megabytes. The max uploads are 500 at any given time in parallel. Last but not least, we are defining certificates. Awesome. As we're through the config map, we're going to write in quit, and we're going to take a look at the service. We need a service to be able to reach our pods with vim php svc.yaml. What are we doing in this service? The kind is a service. It is called PHP, and the namespace is Nextcloud. The specs are the ports we define. We call them PHP as well. The port is 9000, and the target ports in which we can reach our containers is 9000 as well. It is a TCP, and we have the selector with the app PHP. Alright, the service is complete. We're going to write in quit. Now the last piece we still need is our PHP deployment. So let's walk through that file next. Vim php deploy.yaml. We will bring our deployment in and walk through those details. We have a deployment called PHP in the namespace Nextcloud. We have the spec with 5 replicas. We have a label, or selector rather, with matching labels called app PHP. The template contains the same labels. Next are the specs within the template, and we define the volumes first. At first, we define the web root. The persistent volume claim we'll have is called Nextcloud, and we went through that earlier. Outcommented is the Nextcloud data, which I'm not using. The next volume that I'm specifying are the config maps that we just went through. And last but not least, we're defining the time zone again. The containers that we have are the PHP container, that's the name. The image sits on quay.io. The image pull policy is always, as usual. You can also change it to if not present. Ports, we define the PHP FPM port with 9000. We mount the volumes web root, and that will be mounted into var www.html. Again, we are ignoring the Nextcloud data. Next, we are mounting the PHP config maps into, or rather one particular config map, into the user local etc phpfpm.d www.conf, and we're using the www.conf file. If you remember back, we had 4 different files in the config map, and now we're accessing the www.conf, and we're mounting that in the folder user local etc phpfpm.d. Next, we do a similar thing with the Redis session ini. We are mounting that into the etc phpconf.d folder. The subpath is the Redis session. The subpath in the config map is the redis session.ini. Next is the logging ini. We do the same thing and mount that into the same path as the Redis. PHP config maps are mounted in the same folder here, or rather the Nextcloud ini is mounted into the same folder as the 2 above. Last but not least, we are mounting the time zone into etc local time to make error analysis a bit easier. It's not quite long, but it's a longer deployment, but still not very complicated. All right. We are done with that file. We're going to write and quit. Wow, that was a lot of work to this point, but we have successfully made it through the PHP part of our Nextcloud deployment. So let's deploy all these files and see that PHP is starting up. First, we're going to start the watch again. kubectl get all-n Nextcloud. Then we're going to start with a config map. kubectl apply-f php config kubectl get cm-n Nextcloud. So now we see our PHP conf maps, and we have 4 config maps within this one file. Next is we're going to deploy the storage now. kubectl apply -fpvc.yaml. It's created. kubectl ctl get pvc-n nextcloud. Perfect. Our storage is bound and we have 20 gigabytes available. The next step, we're going to deploy the deployment kubectl apply-f php deployment. And we will start seeing the containers coming alive. Our first PHP pod is running. That means so far everything worked fine. The second one, third, while the others still take a little bit, let's now also deploy our service, which is the last piece of the PHP implementation we need to deploy. kubectl apply-f php service YAML. The service is created. There is our service, and it's listening on port 90. kubectl. Let's take a quick look at the service a little bit more in detail. Describe service php-and nextcloud. We see that the 3 pods that are already running are part of the service and so the service can actually reach those 3 running pods. As soon as the other 2 will turn ready, we should see 5 in here, but they want to be celebrated a bit before they start up. Now that we have our deployment mostly running, let's move on to the nginx implementation. For that part, we do not need to build a container. We are using one that already exists and provide additional configurations. If you know Nextcloud and its self-checking features, you know that it will warn you if you're not using encryption. If you don't care, you're good to go, but I do, so I want to start by creating a certificate. Now we get to a point where we will be using our infrastructure extensively that we set up during the first few videos of this series. So let's take a look at the certificate that we will be requesting. For that, I'm going to empty my screen, change directories into the nginx, and we have the certificate that we're going to take a look at. The certificate, so we have a kind certificate. The metadata is Nextcloud cert, that's the name. The namespace is Nextcloud. Specs, DNS names, we define our dynamic DNS address, and the next piece is the issuer reference. Previously, we only worked with a staging. That is over now. We will outcomment that, and we will now start working with our production version. It's a cluster issuer, and the secret name that will be created is called Nextcloud Cert TLS. That's already it, so we're going to write and quit. Great. Before we deploy the certificate in our cluster, however, I want to watch the process of the certificate chain, which means we will watch the challenge certificate request, the certificate itself, the orders and the secret, and wait until the secret is created and approved. That way we will immediately see should something not work. For that purpose, I'm going to stop the watch on the right and start a different watch for the TLS secret that we are about to create. This command is watch kubectl get challenge certificate request certificate secret and orders in the namespace Nextcloud. And it's basically the same that we used in the video 902, just for a different namespace. Okay, let's start the watch, and on the left hand side we are going to apply our certificate kubectl apply-f certificate YAML. All right, we see changes happening. Fantastic. Challenge is valid, which is great. The approval, that was the first one that changed. The certificate is ready, which is true. We have a TLS secret with data in it, which came back from our from the cert manager, and the state of the order is valid. We just received a valid certificate from our cert manager, and this is not a staging certificate, this is a production certificate. So that piece was successful, so we can move on to the next piece of the nginx deployment. Just for completion purposes, let's quickly describe the secret. kubectl describe secret nextcloud cert TLS-n nextcloud, and we see we have a TLS key and a certificate. It was issued by the DuckDNS production issuer, which is fantastic, and it is issued for our domain, obviously. Great, now that we have the secret, let's walk through the config map for Nextcloud. This config map consists of 3 pieces. Number 1, let's bring in the config map first, is the nginx.conf. This file is the basis for nginx and exists in any installation you might have, a virtual server, a container, or a bare metal. This file describes how nginx behaves. At first, we define the user that runs the web server. We automate the worker processes and define a few warning logs, access logs, and fast CGI buffers. Last but not least, we define to include additional files that are in the folder nginx-conf-d and have an ending in conf. File number 2, or part 2 if you will, is the file called default conf template. That file contains basic web server settings, such as where to listen for traffic and which ports. As you can see, we have 2. One is for port 80, the other for the encrypted port 443. Within the encryption, we have to use the certificates to make sure traffic can actually be encrypted. What you can also see is that there are still variables within the 2 server sections. Like I mentioned earlier, this file will be mounted in a special location. The starting container will recognize that location and the file, and will apply the appropriate environment variables to this file, replace it with a desired value so that our nginx web server will function properly. File number 3 is the Nextcloud template. This file contains the remaining commands that are not set in the first 2. Please keep in mind that commands should not exist twice between these files. So I went through the nginx configuration on Nextcloud and made sure that the commands are not duplicated between the files. I have to take a close look at one entry though. As we separated the PHP execution from the web server, we must make sure to let the web server know where to look for the interpreter. There is a line called fastCGI fastCGI pass. That entry will contain the hard-coded information of a PHP handler. Usually it's called PHP handler. That entry we need to replace with the right port so the interpretation can actually work in our containerized environment. We replace this entry with the variable $php_socket. Why and how does that work? Once the container starts up, as the file is mounted to a template folder, this value is being replaced by the starting container with the PHP port that we will set in the environment variables of the nginx container. Once the nginx container finds this variable, it will replace it with the right port and our PHP interpretation will work. Okay, I will not go through all of the entries in this config map, but I will post this map somewhere and will highlight the link in the video. Now that we went through all the supporting files, we will take a look at the deployment. So we're going to write in quit, and we'll get into the file vim next nginx deploy.yaml and paste the contents. Let's start right from the top. We have a client deployment. Nextcloud is its name, and it's going to be in the namespace Nextcloud. We have labels, app. We have match labels at Nextcloud. We have one replica. We have the template in which we define the same label as above. And we're going to start with the volumes. Volume 1 is the web root, and we're using the same persistent volume claim as we did in the PHP handler. That way, both applications access the same storage and have access to the same files. We are going to out-comment the second persistent volume claim as it doesn't exist. That would just cause errors during the implementation. Next is a config map, the nginx config that we just went through, and we declare that a volume. Next is the time zone, and we went through that a few times before. Next, we have the secret, the TLS certificates, which we declare in here, and the secret name is Nextcloud cert TLS. That will be fine. Next, we have the container definitions, and we have an nginx container. We use the nginx alpine image. We have the image pull policy set to always. Now we get to the important part. The environment variables. I indicated that before, and here we have them now. The PHP socket. So we define a environment variable which is called PHP socket. Spelled exactly the same way as we just went through the config map, and the value is PHP 9000. What that will do is it will send a request to a PHP service, PHP, the first three letters, at port 9000. And if you remember back into our PHP deployment, that's exactly what we defined there. Next, we have the web root variable which we define, and we set that to var www.html. Next, we define includes. So we include an additional configuration file which is called Nextcloud include. Please do not call these files .conf. It would not work. I've tried that because I thought I want to have those files consistent and the file names too. It will not work. You must call it include, otherwise the nginx will interpret the file the wrong way. Will be brackets, curly brackets missing, and it will not work. With the include here, it will. So the include is the environment variable, and the value that it will contain is include, and the link to the Nextcloud include file. Next, we define ports at port 80 and 443. We want to declare both ports, even though we would prefer the encrypted connection over 443. But for the startup, we should have both ports just in case one doesn't work. And we will find that out later when we deploy Nextcloud finally. Volume mounts. Now we mount the web root into var www.html. We do not have the Nextcloud data, so we're out commenting that. And next we mount all the files that we went through in the configuration map now. The first one is the nginx, which we mount into the nginx folder under etc, the nginx conf. The next file we are mounting are the template files that need to be updated upon the startup of the container. That's why they are mounted in the templates folder underneath etc nginx. Once the starting container finds these files, the environment variables will be replacing the placeholders, and then the files will work. So we do the same thing for the default conf template and the Nextcloud include template. And last but not least, we're mounting our time zone in the local time. Obviously, we also need the certificates mounted, and we mount our TLS cert, which contains the TLS cert and the TLS key, and they are both mounted under the etc SSL nginx. That's already it for the deployment, and we can write and quit. I'm going to empty our screen, and we'll review the last file we need, which is the service. nginx service.yaml. As you can see, that service is straightforward. We have a kind service. We call it Nextcloud in the namespace Nextcloud. We declare two ports. One is port 80 on TCP, and the other one is HTTPS on port 443, and it's TCP as well. The app selector is Nextcloud, and we are through the service. I'm going to write and quit. All right, before we start deploying the application, let's stop the watch of the certificate and start the watch again on the namespace Nextcloud, so we can see what happens once we deploy our application. Okay, and we will start deploying the config map first. kubectl apply-f Nextcloud CM YAML kubectl get cm-n Nextcloud, and there is our nginx config right here. Should have called it nginx instead of Nextcloud CM YAML, but that is totally fine. Next piece we're going to deploy is the deployment itself. kubectl apply-f nginx deployment YAML. We should see a container coming up, and we'll wait for its successful startup. We have successfully deployed, after 15-17 seconds, the web server, which is fantastic. Last but not least, we deploy our service. kubectl apply-f nginx service YAML. our services in as well. And now we'll take a look at that service. We see the ports 80 and 443 are running, and we'll describe this. We see Nextcloud -n Nextcloud. We see that the endpoint has been found on 443 and on port 80. Perfect. As our service works completely and can find its endpoint, that concludes this video. In the next video, I will deploy the ingress resource and we will install the Nextcloud instance. The front and backends are prepared and we are ready for an awesome Nextcloud experience. In summary, what is working? We have the backend with Redis and 2EM proxy, aka Nutcracker, in place. The front end with a PHP interpreter and nginx web server are ready to receive traffic. And we have a production-grade certificate in place, which allows us to encrypt traffic. What's next? Next step is to set up the ingress controller, download the Nextcloud zip file, unpack it, and set up our instance. However, if you think that is a walk in the park, don't miss out on the next video. Spoiler alert, not quite. But that is a story for another day. With that, that's it for this video. Thank you so much for watching, and I will see you in the next one.